Here are a few questions from the paper Classical Mechanics. We have to go through them one by one. The first question is, what's meant by a rigid body? Consider 2 points. This is I, this is J. The 2 points are connected and the distance between the 2 points is fixed. This is called rigid body. This Rij equal to a constant Cij. Now go through this statement. A body is said to be rigid if the relative position of parts of the body remains constant during motion or under the action of extended forces. Now go to the second question. What are the two types of motions of a rigid body? First motion is translational motion and the second one is rotational motion. What are Euler's angles? Euler's angles are the three successive angles of rotations involved when we go from the primed to unprimed system. This is primed system, this is unprimed system. The Euler's angles are pi, theta, psi. Pi is precession angle, theta the nutation angle, psi body angle. Fourth question. What is nutation? A bobbing back and forth motion is called nutation. Bobbing stands for quick up and down motion. Define stable equilibrium. A system's equilibrium position is said to be stable if it returns to its original configuration after a minor disturbance. If the system does not return to its original configuration, it is an unstable equilibrium. You may coin another term, neutral equilibrium. If the system is displaced and has no tendency to move toward or away from the equilibrium configuration, it is said to be in neutral equilibrium. Eighth question is, what are normal modes of vibrations? Consider the coordinates q1, q2, qn are called normal coordinates and omega 1, omega 2, omega 3 and so on are corresponding normal frequencies. Each normal coordinate corresponds to a vibration with only one frequency. These component vibrations are called normal modes of vibrations. Q1 relates to omega 1, Q2 relates to omega 2, Qn relates to omega n. Now go to the ninth question. What are the vibrational modes involved in a linear triatomic molecule? Carbon dioxide is a linear triatomic molecule. Center atom is carbon. Two oxygen atoms are present on either side at equal distances. First motion is pure translation motion, not rotation. In this mode, pure translation of the system as a whole is taken. The atom's displacement is equal and in the same direction. All the atoms are moving in the same direction with equal magnitude. This is pure translation. Next case is symmetric stretching mode. Both the bonds either stretch or compress at the same time. See, this is central carbon. Two oxygen atoms are present like that. Suppose stretching is taken place, two oxygen atoms are moving far away from the central carbon at the same instant of time. If compression is taken place, both the oxygen atoms are moving towards the central carbon at the same instant of time. That is called a symmetric stretching mode. And the final case is asymmetric stretching mode. When one bond gets compressed, the other gets elongated. See this case, this is central carbon to oxygen. One is elongated. This oxygen is elongated. Then this is compressed, which is moving towards the central carbon. See here, this oxygen is moving away from the central carbon, but this oxygen is moving towards the central carbon. It is also moving in the opposite direction. That's all about the asymmetric stretching mode. What are canonical transformations? The transformation of one set of coordinates q suffix I to another set capital Q I by transformation equations of the type q suffix I is a function of q1, q2, qn, t is called point transformation or canonical transformation. You know the canonical equations. Qi dot equal to dou h divided by dou pi. Then pi dot equal to minus dou h divided by dou q I. If this qi is transformed with the help of capital qi dot is equal to plus dou k divided by dou pi. This is capital P. This Hamiltonian should be replaced by another one Hamiltonian k. Then if you replace this small pi dot by capital pi dot, this equation is changed as minus dou. This Hamiltonian h is replaced by the new Hamiltonian k divided by dou q I. Now these transformations are called canonical transformations.